All right, welcome to Chapter 11, Section 9, called Areas of Circles and Sectors. This is for Integrated Math 2 or IM 2. So the first thing you'll see on your screen is a due date. I don't see it on my teacher preview, but you will see it on your student screen. The second thing is the number of attempts. So you always have unlimited attempts on tests, quizzes, and homework. Number of questions just particular to this assignment. Grading policy is always best scores. Whichever attempt is the best one is the one you keep. Partial credit is enabled, so if you answer, 1 of 7 questions correctly, you get credit for 1 question. Or if you answer if there's more than one answer within a question, you can get partial credit within that one question. Please remember, once you start your homework, you must finish it before you print anything else. What that means is once I click start here, down in the bottom right corner of your screen, you will see a submit assignment button. That is how you finish your assignment, is by clicking that button. And what it means when it says you can't work on anything else is the program is literally going to lock all of your other assignments and your resources until you click that submit assignment button. What it's trying to do is leave this attempt open for you. If you don't click that button and you just leave the screen, it's trying to help you and leave this attempt open for you, because not all schools give you unlimited attempts. We do. So it doesn't matter how many times you click submit assignment. You can click it as many times as you would like. Just keep coming in and trying it over and over again. And it will save your place as well. So if you've started the assignment and you've got your green check marks or even partials, it will know that and it will start you back up where you left off. So don't worry about it starting you over again. Make sure, click submit assignment so you don't get locked out of all of your other stuff. The second big reason is the gradebook. You get to see what it affects in the gradebook, and your teacher gets to see what it affects in the gradebook when you click submit assignment. Until you click that button, your account is quite literally frozen. So good habit, always click that button. Up here we have calculator, which is sometimes open. It's not always there. But we always have explanation, example, and message center. Explanation tells you you're going to lose your current question attempt because it's going to give you the answer to this question. So it's not going to give you the answer and let you come type it in. You do have example though, and this will give you something very, very similar to what we're looking at. So this is just kind of reviewing the area formula for a circle. So we do have area equals pi r squared. We definitely want to know that. If you have your notes open, this should be on your notes pages. So you should definitely have your notes open with you while you're doing this. And then this shows you how to work through, what to plug in. It's asking us to use 3.14 for pi instead of the actual pi symbol, things like that. So once you're good with the example, you can close it. You can open another one if you want. You can also message your teacher directly from the screen. It will attach a picture so we know where to come help you. All right, let's go ahead and work on this problem. So really, the main background information we needed was that formula that I kind of sloppily wrote down over here. So remember, pi, they're saying find the area of a circle with radius 5, use the value 3.14 for pi, do not run your answer. So this is pretty common with ALEKS. They want us to use this rounded version of pi because pi goes on and on and on forever. It never terminates and it never repeats. So this is just a simple way to kind of round it off. They also told us to use the radius 5 because they told us that the radius is 5. So it's 5 squared. So we simply just plug these pieces in and we multiply. So we have 3.14 times 5. And I could have typed in 25, or you can do 5 squared. You have to hit this little button for the square. Hit equals. So it's going to be 78.5. It says do not round your answer, right? And be sure to include your units. So no rounding. And it's an area. So it's not a length. That would be meters. That's the radius. Area meaning kind of we're taking up a 2-dimensional space, like length and width. So that's squared. So it's 2-dimensional. All right, next we have circumference and area of a circle. So now they're giving us the diameter is 3. So we're going to use the same formula, but remember diameter equals 2 radii. So if the diameter is 3, then I just need to divide by 2. And that'll tell me that it's 3 halves for the radii. I can use the diameter in the circumference formula, but I can't use it in the area formula. So I need to make sure I convert it for the area. Because circumference is 2 pi r, or circumference can also be diameter times pi, because 2r is the diameter, right? That's the same thing. We just wrote that up there. So I can kind of interchange these ones. So I can use this one and go the circumference equals 3 times 3.14 I don't need to have that one converted, but I do need to multiply 3.14. So I get 9.42. Now remember, circumference is not area. That is a length. I want to know, how far is it around the outside of the circle? What's the length? That's just meters. When we do area, that's going to be meters squared. So I can actually type that already, and I just need to know the number. So we're going to use pi r squared, and r is 3/2, which if I actually do the decimal for that, it's 1.5 squared. If you didn't know that, I believe you can actually still type it in this way. So 3.14 times 3 divided by 2. It'll type in the fraction for you. You just need to make sure, because you're squaring this, so you want to highlight the whole thing and let's see, well, let me do this. There we go. I wanted to put the whole thing in parentheses. It wasn't letting me do it for a second. Like that. So I want to make sure I do that because I want to square the whole thing like that. So if you turn it into a decimal first, maybe a little bit easier to type in, but not a big deal. So I have kind of a longer number there, but that's all right. It said do not round, so we're not rounding anything. We're going to type in that whole piece there. So the area is 7.065 or 7 65 thousandths meters squared. All right. It probably would have accepted it as a fraction as well. So find the area and the circumference of the circle with the radius 6. So we're just practicing this guy again. This time, though, they're having us use pi as pi. They don't actually want us to use 3.14. So I already have the radius 6. So circumference, c equals 2 times pi times 6. They want us to leave pi alone, so I'm just going to multiply 2 and 6, and I'm going to get 12 pi. So this is not area, this is circumference. So it's 12 pi. Circumference is just the length, so it's going to be kilometers. The area, that's going to be the kilometers squared. So area is going to be pi times r squared. So r squared is 36, and then I put the pi on the end. That's a really ugly pi symbol. There we go. A little bit better. So I have 36 pi, and this is going to be the kilometer squared because this is the area. This is like the two-dimensional. This is one-dimensional, two-dimensional. And I can see that. Technically, there's a 1 there for the exponent. There's a 2 there for the exponent. The 3 for the exponent means it's three-dimensional, like a sphere. It's a 3D object, not just a flat object. So just make sure you pay attention to your units. All right, number 4. So we're going to kind of apply this, and let me see. I'm just going to get a new sheet instead of taking the time to erase all that. All right, so we have a ring-shaped region is shown below. Its inner radius is 18 inches. So you can see that. Here's the inner one. So we have an inner circle and we have an outer circle. The width of the ring is 5 inches. So that means that it's another 5 inches here. So I know I can get the radius of the whole circle by just adding 18 and 5. So I have 2 circles here. So I'm going to go like this. And then I'm going to do a slightly bigger one. Like that. Like that. All right, so I have 2 circles here, right? So I'm just trying to draw these out. So I have one that has 18 inches, and then one that's 18 plus 5 inches, which 18 plus 5 is 23 inches. So I have 2 circles that I know the radius of, right? So they want us to find the area of just the shaded region. So if I know the area of this guy, and then I know the area of this guy, the difference between the 2 is going to be the shaded region. I can just subtract. I need this one because I want to subtract this area from the circle. I know I'm doing that really horrible, but I want to subtract that 18-inch circle from there, and that'll leave behind the shaded region. So they do this sometimes with other shapes, but I think they're going to focus on circles for this one. So we're going to go area equals pi times r squared. So that's this one. And we're using 3.1 for pi, so 3.14 times 18 squared equals, so that's the area of the smaller, the inner circle. And I'll write this guy down. 0.1736. Ooh, that's a 3. It's an ugly 3. I don't know what happened to that 3. There we go. All right, so now I'm going to do the area of the larger square. And so that's going to be pi times 23 squared. So let's go over here and go 3.14. Ooh. Didn't get rid of all that stuff because I clicked on it, that's why. Times 23 squared equals, so this is the whole circle. Remember, I don't want this piece. I want to actually delete, like erase this piece. So in math terms, but to do that, it means I'm going to subtract it away. I don't want to know, I don't want it there anymore. I only want to know what the outer ring is. So if I subtract the two, I get 643.7, and it says do not round. So I'm going to just put that whole thing in there. So I just copied and pasted it in so I didn't have to type it. All right. So let's keep on going. So now we have a different shape here. So let's go ahead and get a new board. So a rectangle is placed around a semicircle as shown below. The width of the rectangle is 6 yards, which they're telling us. Like we see that here, right? Find the area of the shaded region. So we only want these little corner pieces here, right? We want to kind of erase or subtract all of this away. So how are we going to do that? Well, if we kind of think through it a little bit, kind of slow down. This is a semicircle, which means it's half a circle. So that means that this is a diameter, which means that this is a radius, and this is a radius. Ooh, we have some radii going on here. So if the side length here is 6, then the radius is 6. Well, this is also a radius, which means that this is 6. This is another radius, which means this is 6. So we have length and width now. So the area of the rectangle, which I need the whole area of the whole figure, is length times width, right? So the area is 6 times 12. Remember to add those two together. The whole bottom is 12. So we have 6 times 12. And I'm just going to be a little lazy here and do this on a calculator. So I have area equals 72. And that's going to be yards squared, right? That's the whole rectangle. That's not our answer yet. Now I need to deal with the circular piece that I don't want. So remember, the area of a circle is pi r squared. That's the whole circle. I'm only dealing with a semicircle. So I want half of that. So make sure you're paying attention, kind of think it through. Make sure that you're giving the pieces that you want to get. So the radius is 6. So I'm going to have 3.14 times 6 squared, and then I'll divide all of that by 2, and that'll tell me what the area of that semicircle is. So 3.14 times 6 squared, which is 36. So I get 113.04, or 113 and 4/10. And I'm going to divide that by 2. So I only have half the circle, because I don't see the whole circle, I only see half of it. So the circle is 56, come on, 56.52, or 56 and 52 hundredths. I said tenths on the last one when I said 4/10. That was hundredths. So I want to take the entire square, which is 72, and subtract that semicircle away. That'll tell me what those corner pieces are. So, and it says again, do not round, so I'm going to copy this whole thing and paste it here, but I do need to choose my units this time. It's still area, so we're still working on squares. All right. So next, let's see. Ooh, now we're going to the pieces of a circle. So we're doing something a little different on this one. We're still going to be using area equals pi r squared, but when it's the sector, when it's only a small piece, we want to actually use kind of a fraction showing that it's a piece. And we've used this before when we were doing arc measurements, if you remember those videos or those when we were doing that in class. So to do a piece of the angle or the area, we take the angle that we're given and divide that by 360. That tells us the piece that we're looking at of the circle. And then we can multiply that by the area formula, pi r squared. And that simply tells us it's not the whole circle. We're just doing it by this small piece. This actually gives us kind of like a percentage of the circle. It's going to give us a decimal or a fraction if we don't reduce it all the way. So with this one, we have a circle with center O. It has a radius of 8 and a central angle that measures 40 degrees here. So perfect. We can go ahead and start doing this. So we have area equals 40 over 360 times pi times r squared, which is 8. And they want us to leave pi as pi this time, not 3.14. So remember, it's 8 squared. So I can start reducing this. I can divide by 10 for both of these. That gets rid of the zeros. 4 and 36 can reduce again. 4 divides by itself once, and it divides into 36 9 times. So I've already reduced this down to 1/9 pi. And then 8 squared, well, that's going to be 64. Well, I can't reduce 9 and 64. Those don't reduce. The only thing that goes into 64 is going to be 8s, 2s, 4s, things like that. 9 only has 3s in it, right? 9 or 3. So those don't reduce. So we're just going to multiply 1 and 64 and leave it over 9 like that. So we're going to have 64 ninths. 64 ninths. That came out funny. And then I'm going to put pi on the end. We do need to make sure we choose our correct unit. It's still area, so we still want to choose that squared. It looks like they would also accept it as a mixed number, but let's see if they accept it as an improper fraction. They do. Okay. So it looks like they would have also accepted it as a mixed number since they have that option here if you wanted to, because 64 ninths is improper. Okay. So now we have the circle below has center O and its radius is 2, so we have our radius. We are given that AOB is 60 degrees, so the central angle here is 60 degrees. And we want to find the length of the arc, ADB, so we want this length, this major arc out here, and then the area of that shaded region. So we're kind of going back to when we were doing arc lengths here at the beginning, so it's been a little while since we've done that. So remember, the central angle is the same as this arc here. So arc AB, if the angle here, the central angle is 60, then that arc is also 60. That's not the arc they're asking us for. They're asking us for the major arc. But remember, if I have this piece and the entire rest of the thing, those two added together are 360 degrees because every circle go all the way around is 360 degrees. So if I want the rest of the arc, I just have to subtract the 60 from 360. That's going to tell me that major arc, which is ADB, is 300 degrees. So that's the, oh, and I'm typing that in already. They want the length there, not the degree. So I do need to go and find the length, which is the circumference. Okay, they're actually asking you for circumference and area here. They're kind of having you do both. So length has to do circumference, area is area. So now we can apply the circumference formula, which is 2 pi r, but I need to make sure I'm doing the piece. So I need to make sure I throw that fraction in there. Okay. So I'm going to divide by 10, reduce that down. I can divide by 5 here and I get 6. Nope. I can divide by 6 and I get 5. I can divide by 6 and I get 6. So I've reduced this down to 5, 6 times 2 pi, oh, and I put r there, which should have been another 2. So times 2. So now I can reduce 2 and 6. I can cross cancel these. 2 divided by 2 is 1. 6 divided by 2 is 3. But now I can't cross cancel anything else. So I'm going to go 5 times 2. Yes, times 1, but that doesn't change anything. So it's 10 over 3 pi. So the length is 10 over 3 and then pi. And they want us to leave it in terms of pi again. This is just a length, so it's just meters. Now they want us to do the area of the shaded region. So we're still going to do the same thing. It's still 300 over 6, 360. But now instead of times 2 pi r, it's going to be times pi r squared, like that. Is that actually going to change anything at all? It's not. Why not? Because it was 2 times 2 for 2 pi r. Well, now it's 2 times 2 for the r squared. It's actually not going to change the calculation at all. We would reduce this down the same way. You can divide by 10. This would become 5. This would become 6. Now we have 2 squared, which would become 4. And I can reduce this by 2. And I can reduce this by 2. And look at that. We end up with 5 times 2 and 3 on the bottom. So we still end up with 10 over 3 pi. These guys actually have the same measurement just because the radius is 2. So 2 times pi times the radius of 2 is the same thing as pi times the radius squared because they're both 2 times 2. So it's just one of those coincidental things. We don't want the m though, we want the m squared. Alrighty, so that was section 9. I do believe that is the end of chapter 11, and I will see you in chapter 12.